Welcome to this short, ease-of-use example of setting up the TCI Model 903S and use of the Blackbird NextGen user interface. For this example, I am setting up the 903S at a convenient park. First, I place the RFDF processor on a bench seat, and then place the antenna on the bench, after which I connected the cable between the RFDF processor and the antenna and turned on the RFDF processor. Note that turning the RFDF processor either on or off requires just a single button press. I then connected a LAN cable to the RFDF processor and ran it to the laptop controller. I then simply turned on the laptop controller, again a single button press. I have set the Blackbird NextGen client application to auto-launch when the laptop is finished booting. After the Blackbird NextGen client application is launched, it takes a further half minute for the Blackbird NextGen server to finish initializing and be ready to accept a connection. When the server is ready, the client automatically connects. Once the Blackbird NextGen server has finished initializing, it continues running whatever task it was running when it was shut down. In this case, I had the 903S configured to survey a range that includes the 900 MHz ISM band. I have the Blackbird NextGen client set to show the map display when it first comes up. You can see that there are a number of signals in the band that I am surveying, predominantly from the Naval Air Station to the northeast. I have with me a simple frequency agile 900 MHz ISM band handheld radio. When I key the radio, you can see the lines of bearing to my location toward the north-northeast. I can also clearly see the frequency hopping nature of this radio on the scrolling spectrogram. If I zoom to this set of emissions, you can see that the map display now only shows bearings to those signals to which I have zoomed on the spectrogram display. Rather than zooming, a simpler approach would have been to have set a preset detector for this type of signal in which I am interested. I have created one called 4JL. This simple detector describes the signal in terms of signal bandwidth and signal duration. The effect of the detector is to filter from the spectrogram display any signal that does not meet the criteria in the detector, which also removes all the bearings from the map except those that meet the criteria for this particular handheld radio. Here I have changed the time period for display to go back 2 minutes, so now I can see the transmission I made about a minute and a half ago, as well as the one that I just made about 30 seconds ago. When I switch back to the map view, you can see that the filter has been applied to all emissions, so that only my signal of interest is displayed. If I simply click on the Internet Explorer-like back button, the filter that I applied is removed, and I can see all signals unfiltered in both the spectrum and map views. Reapplying the filter is as simple as clicking the Forward button, which updates the spectrum and map displays accordingly.